Guys, in this video we are going to see how to determine a potential function of a conservative vector field in three-dimensional space. Now let's look at this given problem. This question is asking, say whether the vector field is conservative, find the small f function such that the vector field function is equal to gradient of the small f function. Here we have the vector field function. To find out whether this function is conservative, we had to find out the curl, and if the curl is equal to 0, this is a conservative vector field function. If the curl is not equal to 0, then this is not conservative. Now to find the curl, what we do is we use this equation. Curl is equal to del operator times not times, the cross product of f. If we cross these two together, that's going to give us the curl. Now we do the cross product using matrix. We put ijk, and then okay, let's leave some space because we have big functions right here. We are going to need some space. So this is our ijk, and after that we are going to put the del operator. Del operator is going to be partial derivative with respect to x, partial derivative with respect to y, partial derivative with respect to z. This is the del operator, and then we put pqr. This is our p, q, r. P is the function that is in front of this I component, q is the function that is in front of this j component, and r is the function that is in front of this k component. Now let's go ahead and copy that function here. Here we are going to have y square c cube, and then we are going to have 2xy z cube, and here we are going to have 3x y square z square. Okay, now we are going to do the cross product. Cross product is same as determinant. Like if you remember, we put plus minus plus, and then we take, like if we take I, we eliminate all the vertical and horizontal part of this one, so we are going to left with this one, this part alone. Okay, then we do the AD minus BC. AD minus BC is this one. If we think as this one as A, B, C, D, then we like multiply AD and then subtract BC. Okay, now here if you cross this one, AD is going to be partial derivative of this function respect to y. Here we have 3xy square z square, and if you take the partial derivative of this one respect to y, this is going to turn into 6xyz square, because this y square will become 2y, but we have 3 already there, so 3 times 2, that's going to be 6. X and z are going to be treated as constant, so this is going to be 6xyz square, 6xyz square, and then we are going to subtract the other side. So we are going to take the partial derivative of this function respect to z, so that's going to turn into 6xyz square again, so minus 6xy z square, and after this is I component, then subtract, because we have minus sign, this is plus minus plus, then subtract, then we pick up the j component. When we take the j component, we eliminate, we now get rid of, let's get rid of this one. When we take the j component, we eliminate this part. Okay, this one was square. Okay, and if we eliminate this one, we are left with this 4. Now if we take the partial derivative of this one with respect to x, that's going to become 3y square z square, because this x is going to become 1. So we are going to have 3y square z square, and after that we subtract other side. So here we are going to take the partial derivative of this one with respect to z. If we do that, this is going to become 3y square z square, because this z cube will become 3z square, and this y square will be treated as a constant, so this is going to remain the same. And after that, this is j, then after that we put plus, and plus after that we are going to take the k component. If we take the k, we eliminate the last one, so this one is going to remain. We eliminate the last one, so we are going to left with this part alone. So if you take the partial derivative of this one with respect to x, this is going to become 2yz cube. Okay, because x is going to become 1, so we are going to have 2yz cube minus, then we are going to take the partial derivative of this one with respect to y. If we do that, this one this is also going to become 2yz cube. Now let's simplify this one. If you see, this is going to become 0, because we have 6xy square, actually 6xyz square. Here also we have 6xyz square. When we subtract both of them, this is going to become 0i, and then we are going to have 3y square z square minus 3y square z square, that's going to be 0. And also here we are going to have, this is k, and 2yz cube minus 2yz cube, that's also going to be 0. So all of them are giving us 0. This means this curl is 0. If the curl is 0, this vector field function is conservative. That's the first part. Now we proved this is a conservative. Now the second question is find the small function f such that the gradient of the small function f is equal to vector field function. To do that part, what we do is, let's get rid of this part because we are going to need some space. Okay, to do that part, what we do is we take p and equate this one to small f partial derivative with respect to x. P is the function that is before this I component, that is y square z cube, y square z cube. Then we take the q and we equate this one to small f partial derivative with respect to y, and that's going to be the function q, that is z, actually 2xyz cube, 2xyz cube. Then we take the function r and we equate that one to partial derivative of small f with respect to z, and then that's going to be 3x y square z square, 3x y square z square. Okay, the question is to find out the f function. To find that function, what we can do is we can integrate this one, the first one. If you integrate this one respect to x, you are going to get, here you are going to have f of x y z, and this is going to become, because we are integrating respect to x, so we are going to have an x right here. Y square z cube will be treated as a constant, so that's going to just remain y square z cube. Since we are only integrating this one with respect to x, we have to add a function that is with y and z. So here we are going to have a function with y and z, and after we integrate this one, this is our answer, right? This is our final answer, but we cannot express like final answer like this because we have this function g of yz. We cannot express like this. We have to find out what is this g of yz value, and then we have to write our final answer. To find this one, what we are going to do is we are going to take the partial derivative of this one with respect to y, and we are going to compare with the partial derivative with the small f with respect to y we already have. So to compare that, we are going to take the partial derivative of this one with respect to y, and let's see what we get. If you do that, this is going to become 2xyz cube, because this y square will become 2y. Then if you multiply that one with this xz cube, that's going to become 2xy z cube. And since we are taking the partial derivative of this one with respect to y, we are going to have gy, then we are going to have y comma z. Okay, now if we compare this function with this one, here you can see this side, the left side is equal because we have partial derivative with respect to y, partial derivative with respect to y. But in the right side we have 2xyz cube. Here also we have 2xyz cube, but we don't have anything else, right? It means this gy y of z should be equal to 0. So we can say gy y z is equal to 0. So if we integrate this one respect to y, this is going to become gy of z, and if we integrate 0 respect to y, this is going to become just k. Okay, so we have a constant. So this one, now instead of this one we are going to write constant, but since we are only integrating this one with respect to y, we have to put another function that is in terms of z. So we are going to have, let's put h of z. So we are going to have k plus h of z. So this is going to be our function right now. Now let's get rid of this part and plug this one right here. Here we are going to have k plus h of z, but this is also not acceptable because we have h of z. We know this k is a constant, we can put it like that, but we cannot leave this h of z. We have to find out what is that values. To find that one, what we are going to do is we are going to again take the partial derivative of this one with respect to z, and then we are going to compare this partial derivative of this small f function with respect to z we have already. So we are going to compare with this one. Now let's get rid of this one. Let's get rid of this one because I'm going to do the partial derivative of this function with respect to z here, f respect to z, and if you do that, this is going to become 3, because this z cube will become 3z square, and if you multiply 3z square with xy square, that's going to become 3xy square z square. Okay, and also we are going to have, that's it, right, because we don't have any other function, and this constant, okay, well, also this constant will become 0, because when you take the derivative of constant, that's going to become 0. This h of z will become h prime of z. Right, now we are going to compare this one with this one, and here the left hand side is equal because we have f of z, fz, and in the right hand side we have 3xy square z square. Here also we have 3xy square z square, but we don't have anything else right here. It means this h prime of z must be equal to 0. So we can say h prime of z is equal to 0. Now to find this h of z, because that's our purpose, we are going to plug this one in the main function, right? Now to find the h of z, what we are going to do is we are going to integrate this one with respect to z, and if you do that, if you integrate a 0, 0, that's going to be a constant again. Now let's call this constant L. Okay, now instead of this h of z, we are going to plug this L. Now here we are going to have this L right here, and here we have two constants. When we have two constants, we can combine them together, and we can call this one a capital K. Okay, so this is going to be our final answer. So this is going to be the function such that the gradient of this function is going to be equivalent to vector field function, and that's how we do this kind of problems. I hope this helps. Thanks for watching.